Good morning, ladies and gentlemen. I did just want to spend some time with you today talking about the information that's in Chapter 4. Chapter 4 is titled Atoms and Elements. In Section 4.1, that's where we first start talking about elements and symbols. But let me go back for just a minute. The career that's mentioned in Chapter 4 is about farming. And so please read over that information. There's some good information there that can help you. But going forward in Chapter 4.1, that's where we start again looking at elements and symbols. And it talks about how all matter is made up of elements. And your book mentions that there's 118 different kinds. We find all the elements that exist and are known about right now on the periodic table. Then it moves into talking about the fact that elements are pure substances that are only made of one kind of atom. In table 4.1, that's where you're introduced to some of the different symbols. And they do give you an explanation of where the names for those symbols come from. What is a chemical symbol? A chemical symbol is an abbreviation that we use to represent an element. Please remember the first letter is always capitalized and the second letter is always lowercase. Currently, there are no three-letter abbreviations for elements on the periodic table. If you see a three-letter abbreviation, that's because that periodic table has not been updated. But currently, all 118 elements have been named and their symbols have been recognized by IUPAC. And so you need to get a more current periodic table. In section 4.2, that's actually where you start talking about the periodic table and the classifications of elements on the periodic table. It also gives you the group names if you're looking at figure 4.1. Notice that your metals on the periodic table are located to the left side of that staircase line, except the element hydrogen, which is not a metal. It's actually a non-metal. But all of your metals that are shown in that blue color on your periodic table in your textbook, they are to the left side of that staircase line. All of your non-metals are located to the right of that staircase line, except for hydrogen. And then your metalloids are the elements that are touching that staircase line, with the exception of the element aluminum. We know that aluminum is underneath the staircase line, but we also know that aluminum is a metal, that it is not a metalloid. And so when we start talking about the properties of the elements, there's some things that you need to be familiar with, like the group numbers and the different group names. When we say group, we're talking about elements that are in the same family or in the same column on the periodic table. The group numbers are written at the top of those columns. And so you will notice there are 18 columns on the periodic table, and each one of those 18 columns gets a 1 to 18 number, but it also gets an A number or a B number. The A numbers are very important because they tell us that we're dealing with the representative elements on the periodic table. Your B numbers are your transition elements that are on the periodic table. And you will also notice that the periodic table has 7 rows, and those rows we call periods. Those rows we call periods. And so you'll notice that there are those 7 rows, and then you'll probably also notice that there are 2 rows that are pulled out of the periodic table and they are under the main body of the periodic table. Those 2 rows actually belong on row 6 and 7 of your periodic table, so don't forget about those elements that are listed there. When we move on to talk about the names of the groups, there are some important names that you need to be familiar with. Like, you should know that elements in column 1 or column 1A are called your alkali metals. They are metals that are, and except for hydrogen, they are generally good conductors of heat and electricity. They're very soft, they're very shiny. They are very reactive with things like water and oxygen. So in nature, these things are never found by themselves. They're always found in compounds. When we move on to group 2A or group 2, we know that those are metals as well. Those elements are called the alkaline earth metals. They are harder than the ones in column 1A. They are still shiny. They are gray. But they are not as reactive as the elements that you find in column 1A. Then when we move to the far side of the periodic table to column 17, we're talking about the elements that are known as halogens. These are nonmetals. They are highly reactive. They never come alone in nature either. They're generally found in compounds. And so the most reactive groups on the periodic table are your column 1 and your column 17. Your column 1 being your most active metals, your column 17 being your most active nonmetals. And then we also have group number 18, which we know as the noble gases. And these gases are noble gases or inert gases because they don't generally react with other things. And we'll talk about why that is in a little bit. Now, please remember, when we start talking about the classifications, our metals, our nonmetals, and our metalloids, there are properties that are associated with each of those categories. Like, for example, most metals are generally shiny solids. They can be drawn into wires, and that is actually a phenomenon known as ductility. They're ductile, they can be drawn into wires, or they can be hammered into sheets, which means they are malleable. Again, metals are really good conductors of heat and electricity. They melt at very high temperatures. They are generally all solid at room temperature, with the exception of mercury, which is a liquid at room temperature. Your nonmetals, on the other hand, are not shiny, they're not ductile, and they're not malleable. They are really poor conductors of heat and electricity. Generally, if they're solids, they're going to be brittle, which means that they break apart easily. And so they basically have properties that are completely opposites of metals. Okay. And then your metalloids. Your metalloids, again, are those elements that are touching the stair-step line, with the exception of aluminum. Metalloids have properties that are similar to those of metals, but they can also have properties that are similar to those of nonmetals. And there are some metalloids that are a little bit more conductive of heat and electricity than even metals. And so we call those semiconductors, and they're generally used to make like computer chip components because they are such good conductors of heat and electricity. So you should know those properties of metals, nonmetals, and metalloids. Then in table 4.4, your book talks about the amount of essential elements that a person needs to have as part of their diet, so that and it tells you what those elements function is in the body, what that particular element is needed for. And then in section 4.3, that's where we go into the history of the atom, starting with John Dalton and his atomic theory. We find out that Dalton made his theory in about the early 1900s. And so we found out that there were a lot of things about atoms that we did not necessarily know with his atomic theory. Most of what he said was true. Your book points out 4 points that he made. And of those 4 points, again, 3 of them were true. There was only one that was not true. And that one was the fact that Dalton believed that all elements of the same atom were exactly the same. We, however, found out later that that was not the case. And so through John Dalton and some other scientists that followed him, we became aware of subatomic particles, which are particles that are smaller than your atom. It was with J.J. Thompson that we found out about the electrons in an atom, and because we knew that atoms were neutrally charged, we know that if there are negative charges in the atom, there also have to be positive charges. And so J.J. Thompson came up with his model, which is known as the plum pudding model, where he had the negative charge being spread out in the positive matrix of the atom. Now, we don't really eat plum pudding in the United States, so I always tell students to think of this model as being like the chocolate chip ice cream model. If you think about what chocolate chip ice cream is like, you have the chocolate chips being spread out throughout the vanilla ice cream. That's kind of what the plum pudding model was like. It was after J.J. Thompson. It was Ernest Rutherford who actually found out that Thompson's model was not quite right, and he found that out doing the gold foil experiment. In his gold foil experiment, he was the first scientist who was able to actually locate the nucleus of the atom, and he figured out that in the nucleus of the atom, that's where you have your protons and your neutrons. He also figured out that the electrons were located outside of the nucleus, and that led us to determining the mass of the atom and coming up with the units, the atomic mass unit, or the AMUs, because the particles in atoms are so small. Because the particles in atoms are so small, they had to come up with a unit, and we know that for the mass of an atom, we get that by adding the number of protons and neutrons that there are. The electrons are so small, they don't contribute much to the mass at all. And so when you look at an element on the periodic table, there's some information there that you will see. Our periodic table that we use today is organized by atomic number. Your atomic number is a whole number. It's actually the small whole number that's given in each one of the boxes on the periodic table. It tells you how many protons there are in an atom, because it's the protons that determine what the atom actually is. And so your atomic number is going to be equal to your proton number. Your mass number, again, we find by adding protons and neutrons. So if I know what the mass number is, I can find the number of neutrons. And so you need to be able to do that. And we also learned about isotopes because there were elements that we found that had different mass numbers, but they had the same number of protons. And so remember that an isotope is actually an element or an atom of an element that has a different mass number, and it has a different mass number because it has a different number of protons. And so you need to be familiar with how to write isotopic notation. There are a couple different ways you can do that. So one of the ways is if you show the mass number on the top, show the atomic number on the bottom, and the symbol. This is one way that we write isotopic notation. The mass number telling us, again, the total of the protons and neutrons, the atomic number telling us the number of protons. So if I'm given this isotope, I can tell you in this isotope there are 12 protons, and because it's an atom, we also know that there are 12 electrons. And to find our neutrons, we would just take our mass number and subtract our atomic number to figure out how many neutrons there were. And so that is one isotope of magnesium. I could also have magnesium 25, which has 12 protons. It's got 12 electrons, but now it has 13 neutrons. And that's what makes these two isotopes of one another. Another way that you can write isotopic notation is you can write the name of the element and then a hyphen and put the mass number. That tells me what specific isotope that you're dealing with. You can write the name hyphen the mass number, or you could do the symbol hyphen the mass number. All of those mean the same thing. So you do need to be familiar with how to write different elements and their isotopic notation. You will have to practice writing or figuring out protons, neutrons, and electrons. On the periodic table, you're also given another number, which is the atomic mass. There is a difference between the mass number and the atomic mass. Please remember that the atomic mass is a weighted average. It is a weighted average. So you don't just take that number that's on the periodic table and round it to a whole number. That's not how you figure out what the isotopes are. If you have any questions on how to do that, please let me know. You will actually practice doing some of that in some of your upcoming labs. I'm going to stop right here, and I'm going to do a separate video to cover the electrons in the chapter and the periodic trends. If you have any questions on anything I've covered today, please reach out to me and let me know so that we can get those questions answered before your test. I hope you all have a good rest of your day. Thank you so much for being here.